there are two types of representations in control systems. They are block diagram representation and signal flow graph representation. And there is always a necessity to convert one form to another form, that is from block diagram to signal flow graph or from signal flow graph to block diagram. Now we will see how to get the signal flow graph from block diagram. The procedure steps are given here like this. Now step 1, assign nodes at input and output of the block diagram. So we have the block diagram, input is R of S, output is C of S. So input we assign one node and output we assign another node. Similarly, assign nodes at each and every takeoff point and after the each and every summing point. Similarly, if a takeoff point is connected just after the summing point, then take the combination as one node. Or if takeoff point is connected just before the summing point, take two nodes separately. Similarly, if two or more summing points connected adjacently, then we can take the entire combination as one node. And the same case of takeoff point, if two or more takeoff points are adjacently connected, then take one node for the entire combination. Now finally represent the gain of the blocks along with the sign and the direction which is given in the block diagram. We have to take the same direction in the signal flow graph also. To understand the concept, let us look at the example 1. So in this particular problem, we need to draw the signal flow graph and find the transfer function of the given block diagram. The block diagram is shown here. Now if you closely observe the block diagram, we have two blocks G1, G2 which are in the forward path, and we have two feedback paths, one is H1, other one is a unity feedback. Now there are two summing points and input is R, output is C. So we follow the procedure steps to convert the block diagram to signal flow graph. So we assign the nodes. So input R we assign one node, and after first summing point we assign one node which is X1, let us say. Then the second summing point, after that there is a takeoff point. So when takeoff point is after summing point, yes, we need to take the combination as one node, that is X2 I am taking. Similarly, the second takeoff point is X3 and finally the output is C. So these are the nodes. So I take the nodes as it is, R, X1, X2, X3, C. Then we can connect everything with the gains. So 1, G1, G2, again 1, and there are two feedbacks. One is H1, other one is 1. But we have to take it as a minus H1 because of the negative feedback. So minus H1 minus 1. So we can easily use the machine's gain formula to find the transfer function of the system. The transfer function of the system results like this: C by R or C of S by R of S is G1 G2 divided by 1 plus G1 H1 plus G2.